This conference will now be recorded.
Okay, so Redhead developer right here, no cost, right? This came out a while ago. So what Redhead did was they got rid of CentOS, right? Upstream. It's called something else now. See, February 2021. So this is probably not the latest and greatest, but it's pretty close. All right, so the Red Hat developer subscription is individuals is at no cost. Now, what do you get? You get a chance to install Red Hat uh, for free, and you get a chance to subscribe to their repo so you can get updates. And I think you get up to 15 machines. All right. Um, let's see. No cost. Joining the Red Hat developer program. Um, the Red Hat developer subscription for individuals, including Red Hat components such as Red Hat Linux Server. You get the Red Hat collections and application streams. You get the toolset and compilers and numerous infrastructure add-ons. For those that use Ansible, you can use the free Ansible and the free Terraform as well. Any other free software you can install on here, and any dependencies though some of that software may be, right? Because you're connected back to a repo. And so they walk you through what this is. So here's what I was talking about right here. Um, right here. All right, at no cost, this is the Red Hat developer subscription for individuals to support it. It includes an entitlement to register 16 physical or virtual nodes and running Red Hat Linux, Red Hat Enterprise Linux, complete access to Red Hat Enterprise Linux releases, updates, and better. Excuse me. Why is that important? Because if you got security vulnerabilities or something like that, you can take care of that vulnerability. Let me give you a prime example when I'm talking about taking care of a vulnerability. By default, I should, because I have this subscribed to um, um, probably their repos. This is the Yum repo list. So by default, um, I'm probably using a license that's assigned to me for this server from Google Cloud. Right. So that's why you see these repos here. So I'm gonna do a Yum update. It should be pulling the latest and greatest. Right. I have Google Cloud SDK on this machine, so I can talk back and forth to Google Cloud if I needed to. If I wanted to spin up an instance here from my machine to Google Cloud, I could do that. But this machine is on Google Cloud, so it's doing this thing. I'm doing a Yum update. It's reading the repos and doing this thing, and then you get access to the knowledge base articles, portal discussions, and magazines. The big thing out of here is the knowledge base articles, the documentation, how to read the documentation, how to look for things that you may need. Uh, Something you're trying to do, you can drop in into a discussion and start having a discussion with other people who may have a similar problem. Redhead may, notice it, may get involved and say, oh, okay, well, look, we don't want that to happen to you, and go there, start helping you out. Um, mm, 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 mm. For example, if your development system is running Windows, you can use Red Hat. You can create 16 Red Hat Linux virtual nodes on your Windows system using VirtualBox, VMware, or Hyper-V, and then have them connect back up to the Red Hat portal. And then as it registers, and then you can start getting updates and stuff like that. So you can start playing with clustering or what have you, right? So this is what I want, one of the things I want to show you, right? And this is something that you get access to for free, right? The only downfall is if your machine doesn't have enough memory, or you don't have VirtualBox or all that stuff installed and set up, then that could be a problem, right? but you just need to go through the steps to solve them. Actually, it's still going, but as you can see, base OS, RHI, RPMs, app stream, debug, and it's going through and doing this thing right now. All right. So whenever that gets finished, we'll do cockpit. So here is cockpit Redhead. So they came out with cockpit, I don't know, probably, I don't know, Rail 7, Rail 8, Rail 7, Rail 8, I forget when. Yeah, Rail 7 is included, right? So optional, but it's default in Rail 8, yeah. All right, so cockpit, um, it's pretty much like how you would probably use webmin, just like they have here. Gives you a graphical interface to your system so you can see what's going on, the users, you can create users, directories, what have you. And then they walk you through here on how to install Cockpit. So remember I told you Red Hat was, well, in Fedora, they were using DNF as a package manager. So look, I got 6 packages. This is a system that I just spun up, probably 5 more when I started. And you can see here it's already got some updates out there, right? So we're gonna go ahead and now, and this was on Rel 8.5. So we're just gonna go ahead and say yes. Go ahead and install my updates. But we're gonna install Cockpit. We're gonna enable the socket, and the Cockpit socket, which is a particular port. And then I'll be able to web browse from my machine to the machine that's sitting out in Google Cloud. The only reason why I would be able to do that because I believe it runs over port 80 or port 443, but don't quote me on that. We may have to open up some ports, but we're gonna find out. All right, we're gonna find out. So we're gonna walk through these steps and we're gonna install Cockpit, and then we're gonna go to the IP address of that machine and log in and see what happens. I may have to make a user. I may have to make a user of this machine because I think by default it's just taking my SSH keys and so forth. So I may have to make a user and make that user have some root permissions. But nevertheless, we'll get through that. So right here we're gonna enable the socket, then we're gonna open up the firewall rules, and then there's like, hey, as mentioned before, Cockpit can be extended using existing plugins by writing your own, and they're just showing you about writing your own stuff. We're not gonna do that tonight. Oh yeah, and this is just to write your own. Now, okay, it's port 9090, so I'm gonna have to go back into what you call it and open up port 9090. So here, they're showing like, okay, you want to connect to it, you got to go by IP address or host name if you have it set up in DNS, and hit port 9090, and then you drop down here, and you start looking at other machines if you need to add it, and then you could create VMs and so forth. So they just walking you through, what you can do with Cockpit and so forth. Again, it is default in Rail 8. It is not default in Rail 7. So let's see where we're at. It's still doing the thing. All right.
I got
So
a
we're gonna
question.
go ahead.
Do companies use Cockpit? Because I thought it was pretty cool when I saw that introduction lecture, like an hour and 45 minutes.
Mm-hmm.
It was pretty simple, but I'm like, isn't that a security thing? No.
It depends on the company. Some companies may use it. Some companies may not. Most people who are probably enterprise that's spinning up 50,000 machines or something like that, they're probably not using Cockpit.
Yeah. Okay.
But I mean, but it's just something good to know that it's available, right? So you may be
It's so
managing,
easy. My God.
you may
The
be
internet.
managing uh, 2 nodes and just like, look, for simplicity purposes, install Cockpit and keep it pushing. But it's just something to know. It's not. It's not, oh my God, I gotta know it. It's just, hey, here's an option that's available, right? And then let's see, like I said, yeah, then Red Hat beta. Right, so cool. And then when you're in here, when you register your system, I had a system register earlier, I deleted it. So you can go to systems and then you can register your system. Cloud access. I think, yeah, so yeah. Cloud access enabling products for Red Hat. Cloud access give you the freedom to take your Red Hat to the public cloud. So we say, let's just enable a new provider, see what happens. All right, let's select, let's go with AWS, and it'll probably ask me for some credentials. Let's see, register your cloud provider once and enjoy the benefits of cloud access. Set up a connect to the cloud single registration experience, value add, connect with a single registration, add accounts manually. Let's see what happens when I add the accounts manually. Yeah, so here's my account ID that they're asked for, add another account, so forth, blah, blah, blah. Let's go back and let's do enable, and then we'll pick another one. We'll do AWS again, and then let's see what happens if I do single sign on. Just curious. All right. So here, okay, so inside of when we talk about infrastructure, right? We talk about infrastructure in terms of DevSecOps, security, immutable infrastructure. We talk about it in terms of what you see right here, gold images, right? And what does that mean to you, and why do you care? Well, you care for a couple of reasons. One, you care from a perspective of, hey, this particular provider, AWS or Red Hat or Azure or what have you, has a set of images that are already readily available to me as a baseline that I can consider secure, right? And if I use those images, right, I'm starting off with at least a minimum security aspect that meaning the customer and the provider agree upon, right? So we can click on here and go to images, but while we're doing that, I want to go over not just go to images, but I want to talk about Packer from Hashi, right? So when we start talking about Packer and golden images, um, let me go here. I don't know if I want to use tutorials versus this may be okay. All right, so here's what they're stepping through. They say, hey, install Packer and then build your image, right? But this is where we get to baseline what we have in our images. Just like we have our gold images, this is us creating our gold images. We can use what they already have, or we can package our own. Where we know that as an infrastructure team or as a team, we know that anytime we spin up an instance, here's the least three things that need to happen, that need to already be as a baseline in that instance. We know that when we spin up this instance, like we spun up here on Google Cloud, wherever my thing went, here we go. On Google Cloud, here's some things that we know that need to be in there. We need to know Yum needs to have Vim installed. We need to have, we just say Pico install and Nano install. This is just a fake situation, a fake scenario. We can say by default, these three things need to be in my image, right? I don't care about nothing else. These three things need to be in my image. So they can't find Pico. That's fine. We'll do Emacs and Nano. So these are the 3 packages by default that have to be in my image. Now, what does Packer do? Well, Packer say, hey, you wanna build out an image? Okay, fine, cool. Let's build an image. So here, let me blow this up. Here they're saying, okay, you installed Packer. You're gonna make a directory. You're gonna hop over into that directory, and then you're going to set up a T2 micro. You're going to use this particular image or EBS, HVM, and this right here is some owners, and this is probably Hashi as the owner, right? And then the Ubuntu SSH name. But now I could come down here in my build section. I can give it a set of commands to follow in order to create my image. In other words, I'm giving it, hey, install these things. Make sure that it's the latest and greatest updates from Redhead. Make sure that it has Emacs, Nano, and Pico installed in it. And I create my golden image, right? And so when they're talking about golden image over here, let me see, where did I go with that? Sources. All right, golden image right here. Red Hat Cloud has Red Hat gold images. I keep calling them golden because we used to call them golden, but they're gold images. Cloud ready Red Hat VMs available in Red Hat. This is cloud. I forget what CSS would be. Cloud something. Access environments for cloud access customers and an alternative to use using their own custom images for the cloud, right? Gold images are built and maintained by a trusted source and are readily available to cloud access. Now, I'm going to say this is like getting off topic, but not. So platform 1, golden images or Docker containers, I should say, are readily available as well for public consumption. Let me see, platform 1. Let's go platform 1, Docker containers. Yeah, Docker registry is fine. So they actually put out there a while ago that for public consumption from like the DoD perspective that you could use their images and their Docker containers in order to get spun up. What you see mostly across a lot of domains is OCI compliant containers, right? So this comes out of the OCI initiative, right? But the baseline is the same. We're talking about VMs and we're talking about Docker containers, right? But being from a trusted source. So say that you were building a company, a startup or something like that, and you want to get something that's already built, that's already out there. You may not want to pull from Docker Hub. You could pull from Platform 1. You may not want to pull Docker containers from Docker Hub. You may want to Docker Hub. You may want to pull from OCI compliant containers that already they've been scanned and that's a trusted source. Of course, you're supposed to do your own scanning when you're talking about, hey, how can I ensure that this is already secure? So then you get into Aqua Secure, or I should say Aqua Trivi, which should come up right there. Yeah, right. So this is a vulnerability scanner that used for your containers. Some people use Tenable security scanner for VMs. Right. Let's go back. Right here. So it's called a nested scan. Right. And people will come in and they'll scan the VMs to make sure they don't have any issues or so. There is a community edition of this as well too. So, but Tamika, why are you telling us about all these things? Well, all this starts on the premise of what a golden image is. In order to build your infrastructure, say you're playing at home, or you want to spin up say you want to spin up um some bare metal machines and you want to put some VMs on them, but you don't necessarily want to get started from scratch, or you want to use AWS to do, to do something like this, right? Or you may want to do something with Azure, right? And they have them, like, again, they published already out there, real images, not eligible for hybrid benefit, but they talk about what's in them, right? And what the offerings are, right? So let me locate and go images CLI. Let me see if I have my stuff up right here. I'm doing a run now. Yeah, I'm there. So let me just highlight this and I'll bring my screen over. Oh, I need a token. Hold on. Hold on. Is that it? I don't think so. About to find out. I had to refresh my token to log in. No, that's the right one. I figured that wasn't it. I knew it wasn't it. Now I'm gonna go to my portal and then log in. And then we'll search from the portal. Any questions so far? All right, let me go to the portal. Pull this back over. Let's go to the portal. Azure. Oh, no. This one. Oh, that's right. Azure portal. And let's get logged in. All right, in the portal for Azure. All right, so this is what Azure portal looks like. Virtual machines, what do I have running? Nothing. Awesome. Okay, so let's go to their documentation and see if we can find golden machines via the portal, locating it via the portal. Right here. Okay, create a resource. Let's go check it out. All right, follow along. Go to create resources. All right. And then you can see all available offers at the top. View private offers, where they're looking at for that. I don't know what they're looking at for view private offers, but what we're gonna do is do Red. Let me see. And do they have anything for private? See. So we got Rel 8, got I don't know the difference between, I guess this one will be the latest and greatest right here, but that doesn't tell me if it's a golden image. It may be. Start with set. configuration. All right. So, nope. Let's go back. You can see all the private offers at the top of the page. Create resource. And we're looking at everything. View offers a Red Hat. Click view private offers. A Red Hat Linux bring your own license offer is available in the list of private offers. The amount of updated this. So let's go here. Let's click on Azure. Red Hat Gold image. Red Hat Linux bring your own subscription Gold images are now available on Azure. Bring your own subscription. Oh, you guys, do I have to sign up? To access BYOS, customers would need to follow an authorization process and to ensure they are in possession of valid Red Hat entitlements. Okay, so where does this come into play? So suppose you have a subscription for Red Hat, and suppose that you have a license subscription from Red Hat where you have, say, 200 licenses for Red Hat. What happens is, then this is important. If I come here and I spin up a license, if I spin up an instance with Red Hat, with Azure, Azure is going to charge me for that instance that I'm spinning up because there's a license. And then if I take that same system and register it back with, say, my satellite server or Red Hat, I'm going to get charged again. So I'm getting charged twice. So what this BYOS is it allows me to say, hey, use the cloud access, and I'm going to use my own subscription from Red Hat that's going to supply me my golden images in order to spit up inside of a particular cloud. And that's important when you already paid for it, and it's important from a cost perspective. What would be the difference? They're both supplied from Red Hat, but it's just how it's licensed. You may get a deeper discount from your provider from Red Hat, from you being a customer with Red Hat outside of being a customer for Azure. So that could be different. You could be getting not just support as well too. So you could be getting support from Red Hat versus getting support from Azure, depending on what you're doing, right? So that's the major difference. Does that make sense to everybody, what we just went over and showed when we're talking about golden images? We're talking about spinning up, using your subscription from Red Hat and what that cloud access gives you and so forth. Did that make sense? And I'm not looking at the screen.
Yeah.
Okay. All right. So now let's get into it. Cockpit. Let me go find my instructions to install Cockpit. All right, so here we go. I'm gonna just grab this, yum install. And then we're gonna open up some firewall. And as you can see, that here's the dependencies that it uses. So there's a difference between using Yum and using RPM. Yum will go out and grab all the dependencies that's needed. And it's gonna be a minute doing this. And then you have RPM, which doesn't take into consideration there are dependencies. It just installs just that RPM. It doesn't go out and search and say, hey, it'll say, hey, this RPM, say for instance, we just did a cockpit install. Hey, cockpit needs to be installed, but it has 15,000 dependencies. You need to go grab those first before I can install this RPM. Versus Yum will go out to the repository and grab those RPMs and install them, right? So as you can see, so far it's grabbing 78 RPMs, and it's gonna probably come out to I think 200, maybe 150 or something like that, that it has to take care of to install. All right, so we're gonna let that roll while it's doing this thing. All right, so we can close that out. Cool. Do your thing. Let me grab this because it looked like it's moving fast enough. Thought it was gonna be there forever. All right, so here, this is how we're adding the port to be opened up, and then this makes it permanent right here. And then we're gonna just start our cockpit because I don't need to enable. You should enable it, but I don't need to enable it because I'm not gonna have this machine up past tonight. All right, so it's on port 9090. So let me go to my console so we can find out what the IP address is. And port 9090 for this machine is not open. And I'm on Google Cloud and I know it's not open. So we're gonna have to open up that port. So here is the IP address of this machine. And if I hit 9090, it should be closed. It shouldn't render anything, which is what we expect. So now I need to go to my firewall for this machine, and I'll bring my console over. So I need to hop down here to my firewall for this machine. I need to open up 9090. So let's go here. And let's go down to, if I remember how to do this, network, VPC. That's not what I want. Go back. Oh, yeah, that's what I wanted. Firewall right there. All right, go back to network. And then we're gonna hit up firewall. And I think I have a 9090 here, right there, cockpit, right? So I need to add that to my machine. Let me look through. Yeah, I need to add that to my machine. Let's see. Can I edit that? Probably not, but that's okay. Let's make a new one because it's going to a specific target, and that target is not there no more. All right, so let's create a firewall. Cockpit tonight. Adding to new machine. And we leave the logs off now. Target, cockpit, sure, specify ports. We're gonna go here, TCP 90. Hold on, let me get their syntax. Okay, 90 and 9091. I don't think I need that, but we'll double check that. IP ranges, I don't remember the machine, but we're gonna we're not. I can lock it down by my IP address, but we're not gonna do that. target tags, specify target tags. That's fine. All right, create, and it's called Cockpit tonight. All right, so now we need to go back over to our machine once we get it. And then we need to add tags to this machine. And then we're gonna edit, and we're gonna drop down here to firewall tags, and we're gonna say cockpit. Did I do dash tonight? I can't remember. Need to save this now. Where's my save? Screen up there. It is. Now we can go back to firewall rules. I think I did dash tonight or underscore tonight. I can't remember. All right, so let me go back over here to firewall rules because I couldn't remember. Set up network and firewall. Let me go by name. Dash tonight. Okay, I did dash tonight. All right. So in theory, if I go back to this guy here, I may need one more thing. And now open it up for me. So let's do this. Yum install links. And then what I want to do is see if it's actually running. This is a text web browser. This is a cheat whenever you're on an exam and you want to see if something is actually running as a service or something like that. This is a cheat. So I can do like localhost 9090 and see if it's right. Let me go back over here and make sure while that's doing this install. Make sure that this machine is actually I actually had the actual tag correct. I think I did dash tonight, but let's double verify. And hit edit. And then we'll drop down to yeah, cockpit dash tonight. Yep, that's what I got. So what this does is it ties this tag to this machine. So it should be allowing me port 9090 on this machine. But we're about to find out if the service is actually up and running. All right, so this does this thing. It's gonna do is download, install, done. Okay, so now we'll do links, localhost 9090. Waiting for response, yes. Log cookie, yes. Not an absolute. Okay, so here I know the web console is up. So look, I can see that it's up and running, right? It's telling me that I know it's up and running. So I most definitely have something going on with my firewall. So here we're gonna control C out of that. All right. So now we killed that. So we know that it's running on port 9090. We have the right IP address that I'm sure of. Let me double check another browser. I'm pretty sure it's not the browser, but we'll double check it. Yeah, it's not coming in. All right, so let's go grab this IP. Let's go back to our target for here. Let's go back to the network. And let's pull up Cockpit. Let's get Cockpit working. Firewall. Where is my here? So yeah, I wonder if I need no, I just need TCP. I don't need UDP. Let's edit. Oh, target tags to see. Look, it just is this a different one? No, it just got Cockpit. I thought I did Cockpit tonight. That's just the name of it. The target is Cockpit. Okay, that's why it didn't work. So let's go back over here. Go to Compute Engine. And let's go back to this one. And let's hit Edit and change it to Cockpit. Delete Cockpit. Save it. And for those that don't have machines, like if you don't want to open up your firewall rules on your ports at home and all of that, this is another way that you can use Cockpit and play with it. All right, so let's see, reload. There we go. Let's go to advanced, proceed. All right, so I know I don't have a user on here. Let's just user add Tam. Okay, cool. I don't remember. Let's make it hard because we'll get hacked in like 5 seconds if I do something simple. All right. So now we'll go Tam and then we'll go log in. All right. So let me go here. Let me see. Can I enable, turn on administrative privileges? Okay, you now have administrative privileges. Does anybody want to try to log into this machine? Into Cockpit? I can drop this in the chat. And oh man, I can't drop it in there. It won't let me. Hold on. Yeah, it's not letting me. If anybody want to try, you can log in. And I can set you an account and you could just play with this while we're in the class or whatnot. Right. And I can give you an account and then you can just log in, right? So here, what you get logs, you get storage, you get networking accounts. So here's like all the accounts that are set up right now. I'll create a new account. We're just gonna call it Joan. And Joan, we're gonna give you password limeade, capital L and capital A. That's your password.
What is it?
Limeade. You don't like me. Okay. Limeade exclamation. Yep, it like that. So capital L, capital I, lime, like lime juice. And then A, like aid, someone, AID. And with 2 exclamation points. So there you
So
are.
you said capital L, capital A?
Yeah, so lime A, yeah, capital A on that one too.
Okay.
Yeah. And then services. And then these are the services that are disabled and running on the system. Here are different applications. So now I can go to subscription manager and I can use subscription manager and log in if I need to run a diagnostics report on here and so forth. Now, what's also, and then I could also hop on the terminal of the machine, right? And here's the different descriptions. I don't have anything, I'm not connected back to anything right now, but you saw earlier I was connected to, I'm connected to Google Cloud subscriptions. I'm not connected to Red Hat subscriptions, right? And we talked about that with the cloud access. Here's where that comes into play. If you want to know more about software updates, you get, it'll go out and check to see, well, do you have any software updates? Well, I did a Yum update earlier, so I shouldn't have any software updates. You can check to see if SE Linux is on or whatnot. And kernel dump in case you have some type of kernel problems or something like that, you can send that to Red Hat, right? System is up to date. Last checked 136 years ago. I wasn't around. So need to get that fixed, but that may be the date on the machine. So let's go back to the terminal and let's look at date. It's UTC time, right? So I don't think I'm in the sudos file. Oh, I am. So now we need to do, remember we could do a time CTL. What is it? Time zone CTL? I forget what it is. Let's change. I forget. Time zone change Redhead. All right. Let's do a time zone change. Yeah, time date CTL. Okay, that's what it was. Time date CTL. So we're in UTC. We want to change it. Let's make it East Coast time. Let's change it to. Let's change it to New York time. All right. So how do we do that? So we have a time, date, CTL, list, time zones, and use, it's gonna scroll, but let me clear this screen here and pull this up. And what we're gonna do is we're gonna grep for America. And I just know it's America. And when I do a grep and I do a -I, I'm telling it to North Case. So here we have America, right? And we want to change this to New York right here, right? So let's clear. And then let's do a time, date, CTL, set dash time zone to America. And it's new underscore York, like that. Now we do a date. Now we see I have date. If we do time, date, CTL, I'm an E, you see the local and then universal time. And you could change the universal time as well too. Right? So now we have that. So let's go back over here to our, was it subscriptions or software updates? Last check 3 minutes ago. That looks better, right? It looks a whole lot better. I'll reload this page after resolving that. Okay, that's fine. But you saw it. Cool. Make sense, everybody? You saw the steps that I took if you're going to use Google Cloud. If you're going to use AWS, you're going to have to go into your security groups and allow port 9090 open. What my suggestion would be is allow port 9090 open from your IP address to that machine so that it's not open to the world, right? But if you wanted someone else to look at it, you have to put their IP address in there so you can open it up. And now we have access now to the machine from a web browser situation. If I wanted to add another machine in here to manage multiple machines, I could. If I want to reboot this machine, I could. Just a lot of little things that you can get out of this if you're not like really comfortable with being on the command line and so forth, you can always set up your GUI and so forth. But it's just another way to show you like different things you can do with your Linux boxes and so forth, right? So now let's get into what the class has, right? I just wanted to show you what you have options and what's available to you. So now let's go into the chapter. All right, this one, it's this. And this should open up too. That should be open, yeah. But you see the troubleshooting steps that I went through in order to get in. Let's see if Joe can get in. Yep. And turn on administrative privileges. Joan, we need to get you a password. But you're in though. All right, so in chapter 7, you see everything we went through as far as permissions, opening up permissions to that box through, multiple things. Now we're gonna get into permissions on the system. All right, so the goal is to set the file system permissions on the files, list the file system permission on files and directories. And we kind of went over this already, but we're gonna go through it again. Change permissions and ownership, interpreting the Linux file system. And these are the guided exercises. Managing file system permissions, and quizzes and guided exercises I'll leave on you in the lab. The goal is to get through the material and then you get a chance to play with what you feel like you interpreted correctly and what you understood. I try to give you a little bit more juice. So here, interpreting the file system. File permissions control access to files. And we saw this before when we were playing last week with file access, right? So let me go back to a regular user. Who am I? ID-A, right? So in here, number 1, we see SE Linux is turned on. 2, you can see my UID. I'm Tamika. And we also talked about last week that your UID and the GID both start at 1,000. In older versions of Linux, they started at 500. And you see my GID is 1001. So there's another group already at 1,000. And so the next available group was 1001, which started at 1001. And then here's a group, Tamika. And then you can see I'm part of the ADM group, a video group, a Google Tudors group, and SE Linux is turned on. And we know where they're stored at. They're stored in our XE group file. We want to look that up. And we know the user itself is stored in the XE password file, right? But in here, they're saying, hey, files have 3 user categories. And we talked about that, right? When we do a ls-l on /temp, let's just do /temp. Again, remember we talked about it. User for every 3 permissions. First off, this is a directory right here. I'm just looking right here. All right, we have user, and for every 3 we have, oops. I like how you can just move it and it don't really be true. That's just on the screen, but anyway. Users, and then these 3 right here, group, and then the next 3 are other. So again, UGO, right? So they're talking about right here, files have 3 user categories. The file is owned by the user, normally the one who created it. The file is owned by a single group, and the file is owned by usually the primary group of the user who created a file. But this this can be changed, right? So then they get in here. Let's look at this right here. Let's jump over this. They say example group. Okay, we have our user named Joshua. We got a user named Allison. Together, with Joshua and Allison. They're part of a group called Web. And this is me interpreting it. I have not read it, but this is what it looks like to me. And I'll go back and read it. And then they have Allison over here. She's a part of the Will group. Notice Joshua hasn't. Why are you laughing? Notice Joshua is not a part of that, right? So let's go back. So I tell you right here, Joshua is a member of the groups Joshua and Webb. Okay, symbolizing these groups. And Allison is a part of the Allison group, the Will group, and the Webb group. Then Joshua and Allison need to collaborate so they can collaborate together because they have group permissions of the Webb group. But if Allison creates a file, right, or directory, and I think her primary group is probably Allison, but if she changes it to the Will group, Joshua won't be able to access that particular file. So here they got file contents, read, write, execute. We've been over this before. RWX, as you can see it right here, RWX. With all of them turned on, that's a 7, 4, 2, 1. And let me see. I thought I had a good example. Because I went back and grabbed Redhead's documentation, because I thought that's how they break their stuff down is something that you want to look at, right? Let me see. Right? Here's how they break it down. Read, write, execute, UGO, user owner, group owner, other, right? That's them breaking it down for UMask. But we can go back a chapter. Let's go configure. I like to get the PDF. So I like the PDF because I can come here, I can blow this up, and I can hop around in the documentation how I want to. So like here, I changed time zones and displaying time, configuring, managing network access, boot time, configuring security, managing our user accounts, which is something we did last week, log files, package management, right? This is all system administration stuff. Using services, the system services, targets, shutting down, suspending, working with unit files, managing user account in the web console, and that's with Cockpit. Then how do you do it from command line? Managing file permissions, all right? And this is directly from Redhead's website. All right, so they give you this right here. When you see the dash, 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 that's 0. When you see the dash, dash, X, that's 1. As if in the middle, nothing in read and write, nothing in read and execute. It's in the middle, that's a 2. If you got W and X, well, we know X is 1 and W is 2, so that means 1 plus 2 is 3. If it's in the first location, that's a 4. And if it's a R and an X, that's 5, right? R and W is 6, and with them all on is 7, right? And that's what they're trying to show you there. So they're showing you right here when you do an ls minus L. You download the PDF directly from Redhead's website. I just did. Just look up Red Hat Linux 8 configuring basic system settings. And it's a PDF, it's 253 pages long. Here they're showing you they did an ls minus L in some directory. and it got read, write, execute, read, write, then 4 dashes and a period. We know that SE Linux is on. We know that the user is sysadmins, the group is sysadmins, and it's a file. That's the object. It's a file. And this is important right here. This is what I went over last week. Directories are 777. Base permissions of a file are 666. What changes this is the UMask. The UMask for regular users is 002, and a UMask for root user is 022. So that changes that. So let me show you what I'm talking about. As a regular user, I'm gonna go over here to temp. When I touch a file, well, first off, let's type what is my UMask? 002. So when I touch hello, if I'm starting off with permissions of 666, that means when I create this file, my permission is going to be 664. And let's do it ls minus l here, and we see that, right? 664. Now, when I sudo to root, right, and I do a umask, you see my umask is 022. So inside of temp, I'm going to touch /temp hello 2, and we're going to do an ll on temp, and we're going to see, oh, look, you see that? Permissions are read, write, read, read, right? Because my permissions start off at 666, and then I go minus 002. When you start at 0022, that means my permissions are now 644, which is equivalent to what you see here for a root user, for an admin user, right? For the admin user. Not a sudo user, but an admin user. And then as a regular user, it's you can see it's 664, right? So, and they go on to explain that in here as well too, right? So another thing they show, this indicates that the user has no permissions right here, right? And the period right here indicates that the SE Linux context is set for this file. And that's important because this is actually often an interview question. How do you know SE Linux is turned on for that? By just looking at these permissions, right? Permissions for a directory, and they walk you through the same thing here. They're just showing you that you start off at 777 as in its totality, and if you're a user or admin, it changes based upon your UMask on what those permissions will be, right? So then they get down here, user file creation mode. They got the UMask. I won't go through that. You can read that because I just went through that, right? And then they come down here and they give you they try to give you a visual. I didn't think this visual is very good because I think it gives you confusing right here permissions of a file after applying the UMask. Okay. They're saying that the UMask is 137. And they're saying 777 from this 137 gives you a UMask of 640. That's what they're trying to show. Trying to subtract. When I first looked at this, I was like, that didn't make sense. Yeah, I'll put it over there real quick. It's already there, yeah. Yeah, I put the link in Slack earlier. I did. Okay, so again, baseline default file permissions. They're just going over the same thing again and talking about which the UMask being set. I won't get into that because kind of drove that home last week. Now, changing file permissions using symbolic values. So here they're getting into Chmod. This one here, right? Chmod. So basically, here over in temp, so I have permission set to 666 6.4, I'm gonna change that to, I want the permissions to be 6.4.4. So I just do 6.4.4 on hello, and then when I do ls minus l, you'll see 6.4.4. However, you can do symbolic, right? I did the number, but you can do symbolic. You can do plus, minus, or equal to. So they're breaking it down right here where they're showing you, you can use chmod plus or minus permissions. So let me get down here where they show you that at, right? So you could do a chmod, and let's go back up to equal, is remove the existing permission and explicitly define new ones. Remove the permissions from the existing permission with the minus sign and plus to add permissions on top of the permissions that are already there. So we're gonna change permissions here. So they said remove the permissions to read, write, remove the permissions to read, write, and execute the file from the group. So they're basically, you're going chmod g0 equal to myfile.txt. Myfile.txt starts out here as read, write, and then read. So read, write for the user, read, write for the group, and read for the other. We're gonna do a chmod go equal. So we're gonna remove we're gonna remove permissions to read, write, execute from the group owner and others, right? So go equals, and so now we just have RW. My suggestion would be, if you was gonna, the easiest way to do that would be, if I want to remove group and other, I would just do a chmod 600 on hello, and that's gonna accomplish the same thing. They're just showing you a different way. It's up to you on how you want to do it. And then it says to change file permissions on my directory from this to this. Let's look at it. So we got a directory that has 770, and we want to change it to 775. Use this to display, and then here on other, make it read and execute on it. They did a other plus RX, so they give them read and execute on the other. So it says all the read and execute access for all users. So that's the other particular I don't know, little snippet, right? So here they're just saying, they're showing you here that they're adding R and X, where R and X will not add it up here. The other way to do that, on hello, we can see hello right now has nothing. If I want to add read and execute, I could do a chmod 6.0 read and execute 5 on hello. And then we'll do a LL, and you'll see that I have read and write, which I kept, and then I don't have anything on the group, and then on the other I have read and execute, right? So knowing how to add is important. 4 plus 2 plus 1, 4, 4 and 1, like knowing these positions like RWX, knowing those positions 4, 2, 1, it's going to save your life, right? And then they're showing here, I'm using octal. And this is what I was doing, right? Like I said, using the octal way to do it. Oh, where'd it go? No, where'd it go? UMass, no, where'd you go? Let me go back to it. Managing systems, introduction, system target, shutting down, hibernating, importing, web console, editing, command line, managing sudo, managing file permissions, and let's blow that up. Yeah, that's where we're at. Yep. All right. Here I showed you the octal as I was going through it at the same time, so I'm not gonna dive into that. Let's see. We know how to display the UMask. We just type UMask. Displaying the default UMask. Here they're grabbing from Bash RC or from the SC profile. And they're showing you that. Okay. This one, I won't go over this one because this is going to take us out of scope for what we're doing. And we talked about the no login shell last week. All right, let's see what we got going on in our class. All right, so we went through the read, write, execute. Read is type in the chat what read, what the R stands for, what the W stands for, and what the execute, what's the octal numbers that they stand for. You should be able to tell me these right off the bat. That's right, 421. All right. All right, so see, users normally have both read and execute permissions on read-only directory so they can list the directory and have a full read-only access to the content. If the user only has read access on the directory, the files, the names of the file in it can be listed, but no other information, including permissions or timestamps, are available. So this is the part right here. It's kind of important, right? This will be something someone will ask you on a interview if you're doing system administration, right? Someone will ask you something like this. If a user only has execute access on a directory, they cannot list file names in the directory. If they know the name of the file that they have permission to read, they can access the contents of that file from outside of the directory by explicitly specifying the relative file name. And so they're getting into sticky bits. This is what they're leading up to. There's one directory on the entire file system that we use. There are other directories, but there's one main directory that we use that has a sticky bit set to it. So if we cd up to slash and do ls -l, there's one directory that has a sticky bit on it, and that's the temp directory. Right? That T right there is a sticky bit. And we know that the periods tell us what on the ends of these permissions. What do they tell us?
SC Linux is on.
Gotcha. All right. So now when we hop down here, it says a file can be removed by anyone who has ownership of it or write permission to it, write permission to the directory in which the file resides, regardless of the ownership of the permissions on the file itself. This can be overridden with a special permission called a sticky bit. So basically what they're saying, if I cd over the temp, or better yet, we're going to ask you to TAM, and we're going to touch, no, let's exit. Let's ask you to Joan, and then let's touch slash temp Joan.text. Right. So let's exit that, and then let's go over to temp. All right. Now I like to do ls -ltrh. I like to see my stuff at the bottom. So we see that Tamika and Joan have files here, and so does root. I'm going to ask you to Joan, and I am going to on who I changed it, so that may work. I may not. Joan should be able to execute because I changed the permissions to user, group, other. Let's go back. Let's cheat. Let's issue to Tamika. And let's touch Tim. hello tam.txt. All right, I'm cheap. And let's go with 10. All right, so now we see hello dot, this is what I wanted. The permissions to be read, write. And so basically 664. And then we have hello at, for Joan, we have Joan.text at 664, right? So who am I? I'm Joan. I'm going to remove -rf hello -tam.text. And I get operation not permitted, right? I can't, because of this sticky bit that's sitting here. And let's do this too. Oh, it's not that. You don't have permission, Joan. You'll never have permission, Joan. Let's find this out. Let's chmod. Let's see what it was messing with hello tam.text. Let's chmod 664 hello tam.text. Okay. And let's go back to Joan. On /Joan. Now on, I thought I added a, oh, I only did a read. My bad. Okay. 10. All right, so on Tamika now, I got read, or I got 665, right? And who am I? I'm Joan. And do you think Joan can now delete this file? Oh, it's in temp. No. Let's go back, right? And let's chmod 777 on hello tam.text. And let's go back to Joan. And let's do it ls minus lrth on /temp. I do that every time. Do you think Joan can delete this this file now? Who am I? I'm Joan. Do you think Joan can delete this file now? No, she can't. Because the sticky bit won't allow her to. And that's what they're trying to show you here. They're saying a file can be removed by anyone who has ownership of it or file permission to the directory in which the file resides, regardless of the ownership of the permissions on the file itself. This can be overwritten with a special permission, the sticky bit discussed later in this chapter, but we got to it already, right? The sticky bit, and this is where the set UID, the GUID, and all those come into play, is because they are those permissions prevent things from happening underneath the folder structure. So, and then it depends on what you're using too, right? So that's what they're talking about. So let's get into it. See, Linux file permissions work differently than permissions used on Ntfs systems. Ntfs will be your file system if you're using Windows. On Linux permissions apply only to the file or the directory on which they're set. This permission or directory are not inherited automatically by subdirectories and the files within it. However, permissions on a directory can block access to contents. The read permission on a directory in Linux is roughly a list of folders in Windows A write permission is to modify. It implies the ability to delete files and subdirectories. In Linux, if write and the sticky bit are both set on the directory, then only the file or the subdirectory owner may delete that file, which is similar to Windows write permissions. So here they're testing ownership, right? So they did a ls minus L to show you the permissions, 664 on test. And then they said use the -G option to see what the permissions is on the actual directory. So if we did an ls minus LD on temp, you see that it's 777, but then that sticky bit does something different for us, and we've shown that, right? And it says the file, the first character of the long listing is a type file. We know that because it's just nothing there. It's a file, right? This right here. That's what they're trying to say. That's a file. And then we have D is for a directory there, and L is for soft link. We went over this before. This should be sinking in. All right. And it says other characters represent hardware like block devices, character devices, and special purpose devices. So let's exit this. What they're talking about here, if we go to /dev, or if we went to, /dev, and we do ls minus, if we just do LL, you can see C for character devices right here. If we go up, we'll start seeing /dev. Where are my, oh, here we go, block devices right here. Right, those are block devices. Those block devices are usually your hard drives, your partitions. So don't delete those, or you destroy your operating system. Play with them if you want to. All right. Then they get into the next 9 characters, group, student. I don't think we need to cover that because I think we kind of beat that to death. So let's give some examples on file permissions here, which is what they're going to do. The following examples will help illustrate how file permissions interact. For example, we have 4 users with the following group memberships. Okay, we have operator 1, database 1, database 2, and contractor 1. Operator 1 has 2 groups, operator 1 and consultant 1. Database is database 1 and consultant 1. Database 2 is operator 2 and database 2 and contractor, right? It says those users will be working with the following files in the directory, right? So here's the files that are here. We got groups, right? Consultant 1, who's part of consultant 1? Operator 1 and database 1. So when you do stuff like this, right? I think it helps to have a visual. All right. So let's do a visual. Let's do this. This is gonna be very, very sloppy, but whatever. So here, oh, we got a lot of groups here and here. Okay, I'm gonna just call this 01. That don't even look like a 1. All right, we got D1. Forgive my artwork. I'm freestyle. We got D2. This is special needs right now, right? C1. And my circles are not the best, but you get it. Oh, I should call that CO1. Oh, whatever. I think you get it. So we got operator 1, we got database 1, we got database 2, We got contractor 1. We need a consultant 1. And oh, I got consultant 1. I'll do CL for consultant. CL for consultant 1. All right. So we got consultant 1, consultant 1. We don't have operator 2. We got a lot of groups. We're just gonna call this O2. Right? So we know operator 1 is part of O1 and consultant 1, right? And we got database 1 who is a part of database 1 and consultant 1. So we know these two can do collaborative work together. You know, off the rip that these two can't do work together because they're not in the same groups or nothing, right? So, and they got it laid out right here. All right. So we know that on the directory, I mean on the files, we got 664, 646, 664, 6400. I mean 640 on R2 and so forth, right? Those files. So these are all the groups we got. All right. It says the -A option shows the permissions of the hidden file. They're trying to show you that there. And then we talked about that before. Oh, why can't? Hold on. Hold on 1 second. I couldn't get my screen back. Oh, okay. I need to go back to a pointer. Okay, cool. All right, so they're trying to show you here on we'll exit. There's hidden directories. If I just do ls, you wouldn't see it, but if I do ls minus la, if I cdo at home and then do ls minus la, you'll see hidden directories. But if I just do ls, you won't see those directories. Right? So you got ls minus a to show you that. All right. It says what are the permissions on file R file 1? The user that owns that file, R file 1 right here, they're looking right here. The user that owns that file is database 1. The group that is a part of or associated with is consultant 1. It says, we saw it 664, it has read and write, but not execute on the other, and on any of them. The group that owns the file is consultant 1, has read and write, but not execute. All others have read, but not write or execute. And they're talking about the other UGO, others. All right, so I'll leave that there. All right, it says the following table explores the effects set on the permissions for the users. The user operator can change the contents of R file 1. The user operator can change the contents of R file 1. User operator has group permissions operator 1 and consultant 1. And then the user that owns this is database 1, but consultant 1 is shared amongst is what that operator 1 is a part of. So user operator 1 is a member of the consulting group, and that group has both read and write permissions on R file 1. Does everybody see that? Yes, no? All right, cool. All right, the user database 1 can view and modify the contents of R2. So when we go up here and look at R2, R file 2, and we're talking about database 1, database 1 is part of database 1 group and consultant 1 group. So we're looking here. So of course, and they say can view and modify the contents of R file 2. View and modify the contents of R file 2. 9 times out of 10, database 1 is the one that created it. The user, database 1, owns the file and has both read and write permissions on R file 2. Okay, that makes sense. The user operator 1 can view but not modify the contents of R file 2. All right, operator 1, you're part of operator 1 and consultant 1, and we're looking at R file 2. So when we go to R file 2, user group other, the group has only read permissions, cannot modify. The user operator is the member of the consultant group, and that group only has read only permissions, right? And then we come back over here, we look at user database 2. Well, database 2 is part of database 2 and operator 2. And it says the user's database 2 and contractor 1 do not have any access to R file 2. So we're looking at, where am I at? Database 2 and contractor 1. Database 2, contractor 1 they're not in the consultant 1 group, so they don't have access to anything. And the permissions here also lets me know that too, right? So other permissions applies to the user's database 2 and 1. They don't have access, right? Operator 1 is the only user who can change the contents of L file 1. L file 1, right here, is owned by operator and is part of operator 1 and user and group. And the only person that has operator 1 access as a user is operator 1, right? And operator 1 group as well too, right? Just the group. Does all this make sense? Did all that make sense? I won't finish it out because we got to go on. But does that make sense? And let's go here. And
Yes.
all right. So then they give you a quiz. And then they manage the file system. Okay. We did the chmod already. I won't go through that. And they're doing a removal with the permissions. I won't go through that. We did that. And I showed you that. So we're going to move on. All right, managing default permissions and files. Okay, here we go. You ready? All right. After completing this session, control the default permissions of the new files created by the user. Explain the explain the effect of special permissions, use special permissions and default permissions to set the group of owners of the files created in a particular directory. And we got these special permissions, right? SUID, set UID, set GID, and sticky bit. And look how they're set up. User, group, other. Sticky bit is on the last octet. The S bit is on the group, and then the U bit is on, the S bit on, when you're doing U plus S, it's on the user. So, but there's some nuances, and let me see if they get into it down here. Let me look. I'm looking for something in particular. No, they don't get into it. I was looking for when it's capitalized, when you have a capital S versus capital X, right? And they don't get into it here. So let me go back. 1, 2, 3. Does that go back too far? I might have went back too far. All right. So let me pull this up. SUID versus GID, GUID, Redhead. Documentation. I like to look at their stuff. Let me see. Is it coming up? No, I don't see it. Right. I was looking for it earlier. Let me see. Because I want to show when it's a capital X and when it's a lowercase x. And but basically what that is it'll be a capital X versus lowercase x. Basically what it is, the capital X is the execute permission isn't set on the directory, so it makes it capitalized. And if it is, if it's already set, it'll be a lowercase. That's really what it is, but I want to show you that. So let's get into it. All right, the set UID permission on an executable file means the commands run this. So you see here the X is already set. And so there's an S right here instead of a capital S. So let's do this. Let's go over to temp.
How far is
Let's touch a file. What'd you say?
how far is Russia from the USA? Pretty far, right?
I'm not sure what that was. Touch 755 on UID dot text. All right. And then it is ls minus l on UID dot text. And so now, oh, I need to, yeah. Oh, why did it not make it executable? Interesting. Who am I? Yeah. Why can't I do that? Oh, shit. You got me all confused. I'm doing two things at one time. Touch UID.text, which is there, and then Chmod 755 on UID.text. All right. I'm like, what in the world going on? All right, there we go. That's what we want to see. So now, let's do Chmod 744 UID.text. All right, so we can see that's 744 no execute, right? But we're gonna now set the GID on that one, right? So we should be able to do chmod G plus S on UID.text. And then we do an ls minus L on UID.text. You see, there's that capital S because there's no execute permission set there. But if I do touch UID-2.text, chmod 777 or 755 UID-2.text, and then I do a G plus X on UID-2.text, and we're gonna do a ls minus L on UID.text and UID-2.text. And you can see there's the lowercase x because it was already set. So when you see something like this, you're like, oh, that permission wasn't set. The execute permission wasn't set on the file. That's what that comes from. All right. And along listings, you can see that you can identify the set UID by a lowercase s, where you would normally have an X for execute. If the owner does not have execute permissions, this is replaced with a capital S, showing you that. The special permission set GID on a directory means that the files in that directory inherit the group ownership from the directory rather than inherited from the user creating from the creating user. So in other words, on the directory itself, it's going to inherit permissions when the group ID or the group GUID is set, right? And then it also says, this is commonly used on group collaboration directories to automatically change a file from the default private group to the shared private group, or if the files of a directory should always be owned by a specific group. An example is run log journal. So it's got an S set on it. So whatever the directory calls for, that's what's going to happen under that. So let's test this out. So let's make a directory called test something. And we're gonna see, no, let's get out of this directory actually, because that sticky bit is set. Let's make dir up here. And actually, yeah, make dir there. Oh, I can't do it there. Okay, fine. Let's go to my home directory. All right. I'm gonna do ls minus ld on test something. 775, right? We know how that happened, right? The umask is that. Directories are 777. And then we have 777 minus 002. And that gives us 775. And that's how that came, right? All right, so we just made a directory called test something. We're gonna get the permissions on test something to look like this here. So they got it 755, right? So now let's chmod 755 on test something. And we know for a fact that they have an execute there. So now we go do a ls minus ld on test something. We know that we have 755. But now we need to apply that GUID. So now we're gonna do chmod G plus S on test something. And now we're gonna do ls minus ld on test something. So now we got our directory to look just like their directory. All right. Everybody agree with that? The directories, this directory looks just like their directory. Right? So now we have a directory that we could play with. Now it says if the set UID, the set GID is set on an executable file, commands run on an executable file, commands run as the group that owns the file, not as the user that owns the file. It runs as the group that owns the file. In a similar way, it's set up with similar way to set UID. One example is locate. So let's go look at that too. And we'll come back to our directory. Do I not have that on there? Probably not. I didn't mean to exit. Let me go back and find it. Let me go get my thing. Nope, it's not it. I exit out of here. Here we go. Right here. Open browser. My bad. I was already a root user. All right. So what they're saying is, let's go. Who am I? who am I? Right, in ls, and they're saying I can ls user bin. There's no locate there. I know why. So we need to su dash to root sudo dash root. And we need to install yum install mlocate. I think that's where the locate is at. It may not. Does it let me install it? Yeah. Let's see. And this is something I should show you too as well, using the package manager. Okay, so let's do it. ls user bin. No, let's do lo. Hit locate, come up, there we go, locate. I need to do ls myself. All right, so here they're showing you that you have read, write, execute for the root user, but on the user and the group, for the group and the other, sorry, there's an execute on there. So the other, somebody who's not a part of this group can do a locate, but if you're a part of the S locate group, you can also execute. But this S, and that's what they're saying here, if the set GID is set on an executable, commands run as the group that owns the file, right? Not as the user. So it's not running as the root user, it's running as the group that owns the file. It says in a long listen, you can identify the set GID permissions by a lowercase s, where you would normally expect an X to be. If the group does not have execute permissions, it's replaced with a capital S. So we should test the theory out, right? Can it still run? Will it still run if we remove the execute? No. If we make it a capital S, is it still gonna work? Right? It says if the group does not have execute permissions to replace, lastly, the sticky bit for directory sets a special permission on deletion of files. That's what we saw earlier. Only the owner of the file and root can delete the files within the directory. An example is /temp. So they get into here. All right. In a long listing, you can identify sticky permissions by lowercase letters, T, X, and so forth. If the other does not have execute permissions, then they're replaced by a capital T, right? So here's set UID, U plus X, set GID, G plus X, is set sticky for 002. And they give you the numbers of how that's set up again, 421, right? So instead of using G plus X, U plus S, you can do permissions like 4735 or 4777 or what have you, or if you want to set the GID, you would do the 2 or 1. And when I'm saying that, let's go here. So here we got the GID set. So that's equivalent to settings 2755. So let's see if that's true. Jamad 2755 on test something. Let's see if that's still true. We'll do ls minus L. Survey says right. So now if I want to set the UID on here, if I do a chmod 4755 on this, on test something, you can see now that this is set because I just set the GID. And then if I want to do just the permissions on the sticky bit on the other, then I would just do a chmod 1775. Oops, I want to test something. So I got everything set right here, right? But I'm just showing you how that works, how you change it from being just here or doing octal, right? Okay, then they get into default UMask information. We won't touch that. Here is how you change the UMask. So if you change the UMask to 0, it'll be, the default will be all of the user, everybody would get 777 and 666, right? So touch 0 and then and then you see a file is 666. And then if you make a directory, and then you have 777. So now if you do 007, what do you get, right? So because by default, a directory is equal to 777, and a file is equal to 666, right? So how does that work? All right. So they did a touch on a file. We know by default a file is 666, but when they tested it, it's got 660. So basically it just blanked it. And for the directory, it would be 7 minus 7, so it came out with 770, right? So when the number is higher than the last, the default number, the default value, it just makes it 0, it just wiped it out. And here they're saying how you can override your UMask values here, and then from the start, right? That's just what they're showing. But I want to show you something else. Let's touch my file.txt. And we'll do an LL, and you see my file.txt is 664. What happens? What do you think happens if I do a chmod 7664 on my file.txt? What do you think happens? Remember, they told you that up here that this is 421. Remember they told you that right here? What do you think ends up happening? I don't have executable set, right? What do you think? What is that gonna look like? No execute set, right? But notice it changed all the permissions. There was no executable set. So this is what I got. Now let's do touch my file -2.txt. And let's chmod. Let's do it. Let's make it. So my file 2.txt has read, write, right? No execute. So let's put some execute on it. Let's do 775. So let's chmod 775 on my file -2.txt. And now we're gonna use our up arrow. And we're gonna change this to my file.2.dat, and we're gonna change that to 775. And now let's do a ls -l. Now you can see that my file 2 gets the lowercase of my file. My first file got all the uppercase one, and it changed every last bit, right? And then you have the guided exercises and controlling the lab, and you're done. I will go back and study this here. Let's look at that. Type UMask. You can see here if let's spread this out. If the UID is greater than 199 and the UID, if we run this command, is equal to this command, then the UMask will be 002. Else, by default, is 002. That's what they're showing you. These two have to be true. And then in here, bash RC, just type in UMask and then do a search. The same thing. It's true. All right. Cool. The next one up is monitoring processes and controlling services. We're gonna go through those together. I'll stop recording.